Okay, so before we begin, make sure that you have watched the vocab video. That's where you'll learn how to do these things. But we'll review it here again. Review it here again. All right, to divide numbers or variables with the same non-zero base, subtract the exponent. So this is dividing powers with the same base. We did multiplying the other day. So math, what that looks like is 4 to the 5th divided by, remember that fraction bar is divided by, 4 to the 5th divided by 4 squared. Technically, that's 4 to the 5 minus 2, or 4 cubed. And let me show you why that works. So if you think about writing it out completely, so 4 to the 5th is 4 times 4 times 4 times 4 times 4 over 4 times 4. That's our 4 squared. They can cancel each other out. You're left with 4 to the 3rd. So to express it algebraically, that looks like this. A to the m divided by a to the n is a to the m minus n. Again, that's for a for non-zero because we know something to the 0 power. Or can't divide by 0, I should say, right here, right? So that's why that is. But anyway, so again, if I had x squared, right, divided by x to the first power, that'd be x to the 2 minus 1, right? Or x to the first power, or just x really, right? And we'll do lots of examples. So dividing a power by a power. So an example here again is 3 to the 8th power with 3 to the 5th power. That's 3 to the 8 minus 5, which is 3 to the 3rd power, which is 3 times 3 times 3, which is 27. Now you could have done it the hard way. You could have calculated out 3 to the 8th and calculated out 3 to the 5th and then divided the whole thing. You still would have gotten 27. So again, a to the 4th divided by a squared. Again, if you had to think about it, it would be a times a times a times a over a times a, and these guys would cancel out, leaving us with a squared. But again, the rule, the shortcut, when we have division, a to the 4 divided by a to the 2 is a to the 4 minus 2, which leaves with us a squared. Good. Pause, head into class kick, and work a few. If you need help, please do ask. So simplified expression, 10 to the 7th divided by 10 to the 4th, that's 10 to the 7 minus 4, there we go, which is 10 cubed, which we all know is 10 times 10 times 10, which is 1,000. And over here we have x to the 25th divided by x to the 18th. That's like x to the 25th minus 18th, which is just x to the 7th. Go ahead and continue for another example from me. So as a reminder, I think we might have covered this before here, 0 is an exponent. Anything to the 0 power is 1, except for 0 to the 0 power, right? So if I have, again, as long as we understand that the a can't be 0 there. So even if I have 297,841 to the 0 power, that's really the number 1. So here we have another example. Simplify each expression. Negative 8 squared over negative 8 squared, that's, and you should recognize the same thing divided by itself makes it 1, but technically negative 8 to the 2 minus 2, which is negative 8 to the 0, which is defined as 1. That's pretty much right there why it works. Now, sometimes you'll have more stuff involved, right? So here we still take the 6 and the 18 and divide them out. Becomes 1 over 3. You can reduce however you want to look at it. b to the 3rd divided by b to the 3rd. That's b to the 3 minus 3, which is b to the 0, which is the number 1. So I'm just left with that 1/3 because 1 times 1/3 is just 1/3. Go ahead and pause, head into class kick. Your turn. Alrighty. So simplify each expression. As we know here that any number, non-zero number to the 0 power is the number 1. These guys here, we have 5 squared over 5, so that's 5 to the 2 minus 1, and then 6, or x rather, I'm sorry, x to the 6 minus 6. So 5 to the 2 minus 1, well, it's 5 to the 1, or 5 to the first power, which is 5. And 6 minus 6 right, is 0. So x to the 0 power is really the number 1. So it's 5 times 1, which is just plain old 5. On C right here, we have x to the 5th over x to the 5th, right? So it's divided. So it's x to the 5 minus 5 times x. I'm sorry, that's not x, that's a y. Got a little crazy there. So times y to the 6 minus 3. Well, this creates 0, which is just 1. And this is y to the 3rd power. 6 minus 3 is 3, so it's just y cubed. And then finally, over here, we take a look. X to the 0 power becomes the number 1, leaving just the 1/5 times 1, which is just 1/5. If you have questions over those, please do ask. I'll go through and sit with him all you need. Go and continue for another example from me. Now, here's where it gets kind of fun. Like it wasn't fun already, right? Negative exponents. 3 to the negative 2. So here's what I think, okay? If a number, right? If a number has a negative exponent, it's in the wrong place. Think like heaven in the other place, okay? So if I have 4 to the negative 2 power, well, that's like 4 to the negative 2 power over 1. If we think of this as heaven and this is the other place, right? Then this guy's in the wrong place. He belongs down here. So it becomes 1 over 4 squared. It's not just 0. There's technically, 1 times up here. So that's why that works. So if I have, again, any where a is not 0, that's really important here. A to the negative n is 1 over a to the n. So if I gave you x to the negative 3, that becomes 1 over x cubed. That's what we're looking at here. Because here he's in the wrong place. Likewise, let me show you something else here. If instead I had, let's say, 2 over x to the negative 2, this guy's in the wrong place. He goes up. So it becomes 2x squared over 1, or just 2x squared. So even if they're in the other place, right, and you get rid of that negative, it means they belong up top. So it gets rid of it when you move it. Okay, so another example here, using positive exponents. So 5 to the 6th over 5 to the 8th. That's 5 to the 6 minus 8. We would all know that's negative 2, right? 6 minus 8 is negative 2. So if I want to write it as positive exponents, that means 1 over 5 squared. Which 5 squared is 5 times 5, so 1 over 25. If I do the same thing with algebra, I have m squared over m to the 5th. That's m to the 2 minus 5. Or m to the negative 3. Now, if I want to get rid of negative exponents, right, he's in the wrong place, so he goes down, so 1 over m to the 3rd power. Go ahead and pause, head into class cake. Your turn. Alrighty. So we have 4 to the 5th divided by 4 to the 7th. That's 4 to the 5 minus 7, or 4 to the negative 2. Again, he's in the wrong place, so 1 over 4 squared. 4 squared is 16. That's 4 times 4, so 1 over 16 is the simplified version. This one, it's technically a to the 4th minus 6, so a to the 4 minus 6, which is negative 2. So a to the negative 2. And again, positive exponents forces him down, so 1 over a squared. Then finishing up here. So the 3 divided by 9 stays the same, right? So 1 over 3. And this becomes y to the 8 minus 12. So I have 1 times y to the negative 4th over 3. Well, that's not going to do because this is a negative exponent. So it forces him down, right? So 1 over 3y to the 4th. Again, if you need me to go through that one with you in person or whatever, I can happily do that, or anything like it. Continue for another example from me. Okay, so writing without a fraction bar. That means we get to keep the negative exponents. Generally speaking, standard form doesn't allow that. But if I say no fraction bars, you're able to force everybody up or up. This would be theoretically so. So these guys, taking a look here. We start with x squared over x cubed. So that's x to the 2 minus 3. And then y to the 3 minus, there's technically a 1 there, right? 3 minus 1. So 2 minus 3 is negative 1, so x to the negative 1. 3 minus 2 is 1, 3 minus 1 is 2, so y squared. Again, that's not simplified form. That's just doing it without negative exponents is the idea. Using negative exponents. Go ahead and pause, head into class kick. Got another one for you. Alrighty, so we're back here to finish up. So we end up here with b to the 3 minus 9, which is b to the negative 6th. And again, if I said put it in standard form, that would be 1 over b to the 6th. But we didn't say that here. Looking at the m's, we have m to the 3 minus 6. And looking at the n's, we have n to the 2 minus 8. So 3 minus 6 is negative 3. 2 minus 8 is negative 6. And then finally, the x's are x to the 1 minus 5. And the y's are y to the 5 minus 3. So 1 minus 5 is negative 4, so x to the negative 4. 5 minus 3 is 2, so y squared. And that's what we're looking at there.